Okay, good morning class. So today we're looking at Euclidean geometry, circle geometry. We have completed theorem 1, which is angle chord drawn from center to perpendicular to chord by the chord, and its converse, which is line drawn from center, which bisects the chord is perpendicular to the chord. Lesson yesterday we spoke about angle at center is twice the angle at circumference. We proved that theorem as well. Remember that theorem comes in for 6 marks. In this video, in the description box, I will put in the link to the proof to all Euclidean geometry theorems required for the examination purposes. Alright, so at this point we're looking at examples for exercise 9.3. And 9.3 is on page. So 9.3 is on page. Huh? 286. Okay, thank you. Right, so 3a. The angle subtended by the diameter at the circumference of a circle is a right angle. That's what we just spoke about now when we marked it homework of yesterday. Not so. Okay, and here, if AB is the diameter of the circle, this is diameter, then angle C is going to be 90 degrees. Now, so why? If we look at it, it's also that angle at center is twice angle at circumference. So what's the size of this angle at the center? 180. So what's the angle at circumference? 90. So on that account, on that basis, I'm getting theorem 3. Okay. Also remember that this is there an asterisk next to it? No. So what does that mean? It's not a proof theorem. It's not required to be proven in the exam. Theorem 1, A was a requirement to prove, and theorem 2, the one we did yesterday. Okay, you guys understand? Again, the link to the proofs of the theorems will be found in the description box below. Okay, so I would like you guys to make a note of this here, as well as the next one. Yeah, converse. The converse theorem. What did we say? What does converse mean? The opposite or the reverse. 3b, the converse of theorem 3a. If a chord subtend an angle of 90 degrees, can you see now what you notice? What is a chord firstly? It's a line. Yes, going from circumference to circumference. Not so. If a chord subtends an angle of 90 degrees at the circumference of a circle, then that chord is the diameter of the circle. Does that make sense? So if you look at it this way, we have a circle, okay, and we have a diameter subtending an angle there. So if that's PQOR, then what can we say? Then angle R is going to equal 90 degrees. Okay? And when we use this theorem, we say it's angle in semicircle. You see that's a semicircle. Why? The diameter cuts the circle in two. And then the converse to the theorem is, if we got a circle, and we got 90 degrees there. M in X. Okay. If that is the case, what can we conclude? Then we can say that M in is a diameter. Why is that the diameter? Because 90 degrees subtended by chord. Okay, so of course if you at this point, you guys are going to make your notes as needed. Okay. Okay. So at this point we have made our notes. So now we're looking at example 1, and example 1 is on page 285. Okay. So here we are told that XOZ is a diameter. So So if x of z is a diameter, from the theorem that we just used now, with it just the way it's supposed to, what can be determined from there? If that is your diameter. Angle W1 and 2 forms 90 degrees, not so? If I say that, then what's the reason? Angle in semicircle. What else can we say? Y is also 90. Why? Angle in semicircle. Does it make sense, people? Right. So in our mind's eye, that is what we must see. Okay. Then, we are told that W and Y are two further points on the circumference of the circle. W, Wx, Wz, Yz, Xy, and Wo are drawn. Then we are told that X2 is 68 and O2 is 68 and X2 is 42. It says calculate the magnitude of, people, what is magnitude? The size. Okay, so I cut this off by mistake. So let's just get the questions. Calculate the size of x1. Okay, so the first question was x1. The next one was z1 and z2. Okay, so let's go with the first one. Number 1, x1. How are we going to calculate x1? Yes, what do you say? Angle at center. Which twice angle at circumference. Can you see that, people? Remember, this is coming from this arc here. WZ. WZ is subtending an angle at center, and the same arc is subtending an angle at circumference. You can all see that. You all understand. Right. So I'm going to take it away because I don't want the diagram overpopulated. So what can I say? X1 is equal to 68 divided by 2. Why? Angle at center is equal to 2 times angle at circumference. Okay, angle at center is twice angle at circumference. 68 divided by 2 is 34 degrees. So what I do is I write it in on the diagram. Okay, why? So that at one glance, when I look at the diagram, I can, one glance by looking at the diagram, I know exactly what I calculated, so what I can use. Okay, let's go to the second question. The second question says Z1. So Z1 is where? Z1 is there. Okay. How can you calculate Z1? Anybody? Sorry? Sum of triangles. So Z1 is actually equal to, angle Z1 is equal to W2. Not so. Why? Angles opposite equal sides. So Z1 is equal to W2, which is angles opposite equal sides, and it's part of the radius. Okay, so Z1 plus W2 plus 68 is 180, but we can say 2Z1 twice Z1 plus 68 is equal to 180. Why? Sum of triangles, then it's triangle WOZ. So Z1 is equal to 180 minus 68 divided by 2. Gives me 56 degrees. Which means to say Z1 is 56 as well as W1 is 56. People, there was another way I could have done it. I could have worked out O1 first, angles on a straight line, and then go angles at center, twice angles at circumference. You will agree with that? Alternatively, they would have also gotten you full marks. Alternatively, I could have said, and I was hoping somebody would have said, that W1 and 2 is 90 degrees. Why? Angle in semicircle. If we say 90 degrees plus 34 plus Z1 equals 180, sum of triangles. So you see there's three different ways. There's probably more. Another one way that I could have done the same thing. As long as I'm doing it properly and I'm using my reasons as needed, as required, I'll get a full mark for the sum. You guys understand? This is what makes geometry marking so beautiful. No? Because you can use many different methods to get the same answer. Okay. It's nice to see the way some of you think. And it's also to say at this point that some of you don't think, okay? Don't be a joke, no? Right, so let's go to the last one. The last question says, you must calculate Z2. So if you're looking at Z2, here's Z2. Not so. How are you going to calculate Z2? What do we need? We need the size of angle Y. But angle Y is equal to what? 90 degrees. So why is angle Y 90 degrees? Angle in semicircle. Not so. You got angle in semicircle. So what can we say now? 42 degrees plus 90 degrees plus Z2 equals 180. Why? Sum of triangles. And it's triangle XZ1. So angle Z2 is equal to 180 minus 90 minus 42 is 48 degrees. Is that correct? Okay, any confusion there, people? You all understand? Okay. So at this point, there's something to... Okay. That will come in the next year. Okay, any confusion? No? No questions? So at this point, we're going to stop the video. What I would like you guys to do for this period is to do all the odd numbers of exercise 9.3. I'll check your work row by row now, okay?